So dear students, I welcome you for the today's lecture related to the vessels subjected to the internal pressure and the combined loading. Basically, the pressure vessels, they are subjected to the various loads, not only the internal pressure. The internal pressure is one of the various loads that exert on the pressure vessel, but in addition to that we are having the different fittings attached to that, and these are the supports. They're all going to have a combined effect in that, and that is why we have to analyze the different loads. So analyze the structural members subjected to a single type of loading, that is the axially loaded bars, then the shaft in torsion, beams in bending, then different pressure vessels. So all these different stresses, because of all these different factors, these stresses will going to appear or will going to arise in the pressure vessel. So these factors, which are the loading methods, are developed for finding the stresses, strain and deformation. So in the system, the members are required to resist more than one kind of loading, that is the bending moment, then axial forces, then pressure vessels supported as a beam, then shaft in torsion with the bending load. All these are going to affect, and for that purpose we are going to study the combined loading and calculating the resultant stress. This occur in the vessels, not only the vessels, but in the machines, buildings, vehicles, different tools, etc. So everywhere there are various loads which will be acting, and these different loads, they are going to form the resultant stress. So pressure vessels or structural members, they're all subjected to the combined loading, and for that purpose we are going to analyze. So this is possible only under certain conditions, such as no interaction between the various loads. That means because of the one load, the other that is going to affect, that is eliminated. So all these rules are applied to the loading when the equations are derived. So what are the different methods, that is for different stresses they will be arising, that is because of the internal loading, then average normal stresses, then normal forces, then shear forces, bending moment, torsional moment, then for thin wall pressure vessels. So all these are the different factors that is going to affect. Then the different stresses are induced due to the uh, internal pressure, weight of the vessel itself, weight of the vessel and its contents, then wind load acting on the vessel, and the pipeline attached to the vessels. So these are the different five factors which are to be given prominence while we consider the pressure vessel. So one by one we will study all this. So first is the internal pressure. So whenever we talk related to the internal pressure, the circumferential stresses and longitudinal stresses, that is going to be taken into consideration. So Ft is your circumferential or tangential stresses, that is calculated as Pdi plus T, or you can say the D, which is the average one, Pd upon 2T. And the longitudinal or axial stresses, that is the Pdi plus T, This di plus t is nothing but the average diameter, that is your pd upon 4t. The next is your weight of the vessel and the weight of its the contents. So the weight of the vessel itself has to be sustained. The shell thickness should be sufficient so that it should be able to sustain its own weight. First, it has to sustain its own weight. And then second thing, whatever the contents you are loading in that vessel, whatever the contents you are loading in that vessel, that is also to be taken into consideration. So it is the weight of the vessel and the weight of the contents that is going to give you the total weight. So total weight of the vessel and the contents. So stresses will be is equal to weight per unit area. Weight is in kgs per unit area, that is centimeter per square. Now on which area this stresses they will be acting. So whenever you will consider this vessel, now area act on which the stresses that will be acting on this area. So what will be the area that is to be considered for this? That is why the pi into d. D is the average diameter into the thickness. So इस एरिया पे मेरे को considerations करने के हैं. That is pi into the d which is nothing but the di plus t and the thickness t. So the stresses that will be equals to the total weight of the vessel and the contents divided by pi t into the di plus t. Then there are different wind forces which will be acting in addition to that. If the vessel which is situated outside the building, when we will have to consider the outside the building, there the wind load that will be acting on the vessel. Even as we go higher and higher, we will face the higher wind load. So if your vessel height is small, say 2 meter, 3 meter, then the possibility of acting the wind load is reduced, is less. So the forces, wind forces, that is also going to develop the bending moment. This bending moment you have already studied in the strength of material. So whatever the force, applied force, that is going to create the bending moment, and for that purpose you have already studied the its diagram, bending moment diagram. And for that, that is bending moment, that is m upon z, where m is the bending moment and z is the sectional modulus. So the FBM, which is equal to the stress due to the wind force, m, that is the bending moment, upon the z. So it will become FBM, which is equal to m upon z, where z is your sectional modulus of cylindrical vessel and which is calculated as pi d square into the t. Pi d square into the t, that is your sectional modulus for cylindrical vessel. Then there are different attachments to the vessel. So these different attachments to the vessel, that is also going to create a torsion. As we have already talked, the different attachments that will be available to the vessel for the pipeline fittings, and this is going to create a torsion into the vessel. So this torsional force that is going to act over the vessel, and which is nothing but the 2 times t upon pi di into t plus di plus t. So this is the torsional stresses due to the torsion that is to be taken into account. Now in this case, the five different stresses that is to be considered. So first, that is the FT and FA, that is your circumferential stresses and longitudinal stresses. These are occurring because of the internal pressure. Next is your weight of the vessel and its content, which is denoted by FC. FC is the stresses because of the weight of the vessel and the content, which is equal to the total weight W upon pi T into Di plus T. The next is the wind force. Wind force, it is creating the bending moment, which is equal to the M upon Z, and where Z sectional modulus, which is equal to pi di square into the T. And the Fs, which is the pipelines because of the different attachments, which is creating the torque. Fs is the stresses because of the torque, which is equal to 2t upon pi di t into bracket di plus t. So actual stresses in the longitudinal direction, that is the because of the internal vessel, internal pressure, the longitudinal stresses. Now these are my longitudinal stresses. When I am pulling in this direction, my longitudinal stresses are here. Now the weight of the vessel has to be taken into the consideration. So all the weight which will be acting in the downward direction, so this, because of the weight of the vessel and the content of the vessel, that is also considered to be the longitudinal one. And the next is the bending moment. So bending moment, that is also considered to be the longitudinal direction. So the total three different stresses which will be acting in the longitudinal direction, they are the because of the axial stresses, because of the weight of the vessel, and because of the bending moment, that is represented by the FL. Then the resultant stress. So the resultant or the equivalent stress, there are different theories of calculation, different theories for failure. Now here we are considering the shear strain energy theory to calculate the equivalent resultant stress. Shear strain energy theory to calculate the equivalent resistant stress. Fr. So Fr resultant stress, that will be equals to the Ft, which is your circumferential stresses, minus Ft square into Fl, that is nothing but your longitudinal stress, raised to the 2, then Fl square plus 3Fs and whole raised to 1 by 2. So this is the resultant stress that will be developed and which is tensile in nature. So all these are resulted because of the shear strain energy theory. And we are already knowing the different stresses due to the applied force, that is force per unit area. The stresses due to its own weight, that is the weight upon the area. Then stresses due to the bending moment, B upon Z, that is the bending moment upon sectional modulus, and the stresses due to the torque, which is nothing but torque upon the polar moment of inertia. So you are having or knowing all these different formulas, and you can calculate the resultant stress by considering the shear strain energy theory to calculate the resultant equivalent stress.